name is Erica Hirsch, and I'll be looking at if pH has an effect on algal growth. Okay, so a little bit of background about algae that we already know is that they're a large group of eukaryotes, and they can be multicellular or unicellular. They also are, most of them are autotrophs, and they thrive in marine waters. So why do we care about this? I'm sure most of you have heard about the fact that oceans are becoming more acidic, and this is because the carbon dioxide produced from the burning of fossil fuels is getting released into the atmosphere, and once it's in the atmosphere, it needs a place to go, so it ends up getting dissolved into the ocean, which lowers the pH levels of the ocean. And since most algae lives in marine waters, this is kind of relevant. Okay, so for my experiment, we needed a specific kind of algae, and based on another experiment that I'll talk about later, we decided that Nanochlorophyss selena would be the best algae to use. And the Nanochlorophyss there's actually 9 different strands of it, and the selena part is just one of the strands. And a little background on that algae is that it's found mostly in marine waters, which is obviously helpful since that is which we want to look at. And they're very, very small, and this picture up here is a microscopic view of them, so each little circle is just one of the algae. They are also used as food additives for human nutrition, and while I was researching, I also found that it's served in a restaurant in Spain, which I thought was kind of weird because you don't really think about eating an algae that looks like this in normal water. And it's because the restaurant is located on a river that is where it first originated, and it's its natural habitat. And the algae also accumulates a high level of polyunsaturated fatty acids, which leads into one of the experiments that I looked at. It caught the attention of some researchers because it has the potential for biodiesel fuel production. And while they researched this, they looked at many different properties of the algae, and they looked at lipid productivity, fatty acid properties, and the growth rate, which is what I'll be looking at. And they looked at all 9 different strands of the Nanochlorophyss, and they were looking to see which strand favored the properties more. And all of the strands ended up favoring it, but the strand Oceanica was favoring them the most, so that was the best for the biodiesel fuel production. And my other experiment was looking at the same variables that I am, and they also had another variable they were looking at. They looked at how pH affected the lipid content. So for that experiment, what they did, they had different pH levels that they looked at with the algae, and they looked at it for a span of a month, which for my experiment will be changing to only 7 days. And after the experiment was done, they found that pH levels of 8 and 9 had the most growth, and for the lipid content, pH level doesn't actually affect the lipid content. And my hypothesis is that the lower the pH level, the less algae growth there will be, and so the higher the pH level, the more growth there will be. Okay, and for the materials and method for my experiment, like I said earlier, it's all based off the experiment that was done by Bartley. And there will be 5 tanks set up, and in the environment, in the tanks they want like kind of a mock environment. So they used Instant Ocean, which is just a product that you can actually get in pet stores, and it just makes salt water, and it's going to be mixed with non-sterile deionized water. And in each of the tanks there will be one with a pH level of 4, 5, 6, 7, and 8. And we want to start off with the same amount of algae in each tank so we have consistency. And the water will be kept at 20 degrees Celsius, and there will be a 12 to 12 LD light period, which just simply means that there will be 12 hours with the lights on and 12 hours with the lights off. And this will all be kept in a greenhouse, and you'll be able to measure the algae growth by looking at how they absorb the light. And the more light that the algae absorbs, means that there will be less algae in that sample, and the less light that it absorbs means that there is more algae in that sample. These are my references.